Flack math! Give me some math and I'll give you some flack. Flack math!
You guys remember when I did well, if you had the choice, if you had a job this summer that was a month long.
Yeah.
Do you remember that little example? And then I said, so the boss comes to you and says, all right, I can either pay you $1 million today for the whole month, or I can give you a penny today and then double your salary every day for a month. What would you rather do? Do you remember me talking about that? Now, obviously, you can tell by the way I asked it, and that I even asked it, that it's going to be, if you go with the 1 penny the first day, you get over $10 million by the end of the month. $10 million. That's what happens when you you're not just multiplying 1 penny times 2.
Oh wait, so
right?
we double every. Okay, because I was like, oh, yes.
So the first 10 days, you're like, what have I done? Because you get a penny, you get 2 pennies the next day. 4 cents, 8 cents, 16 cents, 32 cents, 64 cents, 128 cents. And then you get all the way down and you've made like maybe a few dollars after the first 10 days. Okay. But it doubles. So what's happening is it increases. It's not like y equals 2x. Y equals 2x looks like this. What's happening is y equals x times 2 or times 2 to the x. Okay, so you're multiplying by 2 every time. So you got 1 cent, 0.01 times 2 to the x. So this is an exponential equation. So what happens is it looks like that. All right, so that's what we're going to talk about today. We're going to talk about exponential growth and decay. All right. So the type of business you want to be in, that you want to own, does not have linear growth, okay? You want exponential growth, okay? When you find the right investment, do you ever see Forrest Gump? Like, I think the best.
So. My mom talks about all these.
Yeah, so he's like, one of the lines is like, Lieutenant Dan talked me into investing in some fruit company. And then you see him with a letter from Apple, basically. And so he invested in Apple like years ago. And obviously Forrest Gump ended up being like one of the richest people, in the movie. It's a fictional movie, but it's a great movie about our history. But anyway, that's the kind of investment you want. You want exponential growth. You want compound interest on your end. But if you put money in the bank, I think we've talked about this. If you put money in the bank, you want there to be interest, but you want there to be compound interest. So like, for example, if you get an interest based on how much money you put in, so let's say you put $20,000 in the bank and you get an interest on that $20,000 the next year, when they calculate interest again, how much to give you, it's not just that percent of that same $20,000. It's that percent of the $20,000 plus the interest that you got from last year. So that's called compound interest. So let's just start talking here. So a function is increasing if the output values increase as the input values increase, right? If it's a positive slope. Exponential growth functions are increasing functions used to model situations where quantity always increases by the same percent for a given time period. So this is like constant speed versus acceleration, right? So when you accelerate, you are not only increasing your speed, but you're increasing how much you speed. If that makes sense, your rate of speed. So it's like a rate of a rate. It is modeled by the function this. So this is what exponential growth looks like. So we're going to talk about exponential growth / decay. Okay, so f of x equals a b to the x. Okay, so where a is greater than 0 and b is greater than 1. Okay, so far so good. So this is a situation where a has to be greater than 0, so you're not multiplying. Are you guys done? What are you guys talking about? This must be freaking hilarious. All right.
Sorry.
Okay, so a function is decreasing if the output values decrease as the input values increase, right? It's negative slope. Its graph falls from left to right. Exponential functions that are decreasing model exponential decay. Okay, so a decay is used to model a situation where a quantity always decreases by the same percent in a given time period. All right, so this is growth. And here is decay. Same equation, same function, but these values change here. So a is still greater than 0, but b is in between 0 and 1. Okay? So it's not a negative number. It just decays because it's fractional. All right, so one common application of exponential growth is calculating the amount of an account that earns interest. This is what we started talking about earlier. Okay, so from lesson 47, the formula to find the amount A in an account with an initial deposit of P, the principal, P stands for principal, interest rate R, years of interest. Here it is. So A equals principal amount times 1 plus R over N all to the NT. So N is the amount, the times per year it's compounded or calculated. T is the number of years. Okay? So, and then principal is your principal, R is your rate, and A is your amount. Okay, so this is, let's calculate some interest here. So simple interest is a little different, but a savings account that earns interest at an annual rate of 4% compounded quarterly, which means 4 times a year. Yes. Okay, so my N would be 4. If it's compounded quarterly, that means it happens 4 times a year. Okay, 4% quarterly. If the account begins with the principal amount of $1,000, what will its rate be after 3 years? So this is just plugging and chugging, guys. Principal amount is 1,000. This is example 1. My rate is 4%, so 0.04 divided by 4, because N is compounded quarterly. And then it's NT. So after how many years? 3 years. So it'd be 4 times 3. Okay. So when you do this, here's what's happening visually. You have to multiply it by 1 because you're trying to figure out how much money is going to be in the bank. So you need the whole $1,000, but then you need the rate of that $1,000. So you're going to do that, but it's going to do it 4 times and all to this exponent. So basically what's happening is this is being multiplied. So you get an amount after the first year, the first time it calculates it, and then you multiply that same thing. So this allows you to multiply it by the same thing because it's like doing all these math problems in one little equation. Okay. So when you get this amount, you can put this in on your calculator and you get $1,126.83. That's a unheard of rate. You will never get that rate in the bank, especially these days. Because that's not a bad living. I mean, you're making $126 a year, but it's passive income. Passive income is the best kind of income because it doesn't require you any work on your part, right? So the reason why banks do this is because they use your money to invest in things and to loan people money. So they are using your money to get money, to earn money. So they have to pay for that. They have to pay for your money to be able to use your money. So that's interest. Okay, so here's the deal. Banks frequently compound interest continuously, meaning that there's no end. Okay, there's no end. So it's just a continuous calculating of the rate. Okay, so when n is infinite, to do this, they use a mathematical constant. Do you know what that exponential constant is? It's E. All right, which is approximately 2.718. This is another irrational number that you are learning. So E is approximately 2.718. All right, the formula to find the value of an account when interest is compounded continuously is real easy. A equals principal amount times e to the n. Nope. Sorry, e to the RT. My eyes are bad. So this is a lot easier than this. You don't have to deal with any of that. But basically what ends up happening is this constant calculating of a rate is going to be all in there. So you basically have P times e to the RT. PERT. Okay, so let's do an example. Example 2 says a savings account earns an annual rate of 4%, compounded continuously. Compounded continuously. Okay, so you just need a couple more factors. You need the account begins with the principal amount of $1,000. What will the value be after 3 years? $1,000 principal. After 3 years, what's it going to be? Now, here's the cool thing. On your calculator, everyone take out your calculator if you have it. There is an E button. If you don't have an E button, then you can use 2.17. Do you have an E button? I don't know.
I see 2.
I do.
Oh, I have 3. Okay.
So pi has to do with the relation between a circle's radius and its diameter. Where does E?
Diameter and circumference.
Oh.
So E is hard to explain.
Oh, yeah. That's
But it's basically it's a compound. It's basically based on compounded exponential growth. Okay, so meaning that to do this thing, mathematical E, which is approximately 2 bits. So to find E is a little bit crazy, but it has to do with limits and basically you're dividing by infinity, but then also taking that exponent, this number divided by infinity to this exponential value. So it's difficult to understand. I don't see an E on mine, but my eyes are really bad. Oh, there it is. E to the X. Okay. All right. Now we're going to deal with E again when we do logarithms and things like that. But it's called a natural logarithm when you find the log base E instead of log base 10 or things like that. But we'll get into that. So we're just going to plug it into this formula. A equals 1,000 times E to the RT. So 0.04 times 3. Okay, so let's calculate that on my calculator here. So I'm going to go 1,000 times, and then I'm going to hit this e to the x, which is I have to push second, and then go e to the x, and I have parentheses there, which is great. So 0.04 times 3, other parenthesis, equals $1,127.49, rounded up to 50 cents. Okay, is that what you guys got? So 127.50. I know, it's so funny. 1127.50. Okay, so after 5 years, so we're going to let Gmo and Avery do this one. So after 5 years of earning continuously compounded interest at the rate of 3.5%, a savings account is worth $3,200. What is its initial value? So
Repeat it one more time so I can,
okay, so 2B says this. After 5 years, so T equals 5, right? After 5 years of earning continuously compounded interest, so basically we're going to use this formula, the PERT formula. A savings account is worth $3,200.
So we're just switching to
Yes.
1,000.
Yes.
200.
So, well, no, because the 1,000, that's what we're looking for the original amount. So we're looking for P.
Okay, so we're
Oh,
gonna
okay, so you gotta change
3,200 times E.
Okay,
We're
so
trying to find R.
3,200 is
You
what
have to
it'll
change
be.
so this is what 3,200 is.
So you have to
That's
change
what you
it.
end up with.
Yeah.
So we're going to just plug in our values. 3,200 is what you end up with. You're looking for P. It is compounded continuously, so you want that E. And then what's RT?
RT is going to be the
Something
point,
like that.
what was it, 3% you said?
3.5%, so 0.035
Times
Five, the
was it
time.
4
Yep.
years or?
is 5. Good.
5 years, and then plug it into your calculator.
Yeah.
So you
All
have
right.
to get the P by itself. Right?
Yeah,
Yeah,
so you would.
you should always P by yourself. So we're just going to divide both sides by this.
Yep.
This is just a value that you can plug into your calculator. You don't want to estimate that and divide it by because it's irrational, right? So this you want to have this E calculation in your final calculation. So you want to divide 3,200 by E to the 0.0355. You can do that on your calculator. Okay, so that's what I'm going to do. I'm going to go 3,200.
Wait, couldn't you just divide all of it by 3,200?
No, because then you don't want to get rid of 3,200 because that you'll bring it over here.
Well,
You
like
want
if
to
you
get
do like times P both sides and then divide 3,200 by both sides.
well if you
Well, if you
multiply
did that, then those cancel. So then it's on the other side.
if you divide both sides by P, then you'll have P on the bottom of there.
Oh, never mind, because it's multiplication. Never mind.
Yeah. So 3,200 divided by parenthesis and then E to the X button. And then that shows up another parenthesis, automatically 0.035 times 5 parenthesis. Okay, so make sure you keep track of your parentheses. Equals. Looks like $2,686.26. Is that what you guys got?
Yep.
All right. 2686, 26. Okay. So this is basic financial calculation. Like there are calculators that do this, that calculate this on the internet. Obviously, you can calculate my interest. You can do all this for you, but it's really not a difficult formula, especially if you're already in the mode of the problem set. So it's easy. You just plug it in. You guys know how to plug and chug. You do this in science all the time too. So just make sure you're putting the right numbers in for the right letters. Okay, so okay, so let's talk just briefly about exponential decay. This kind of thing you don't really, there's not a lot of positive connotation with exponential decay. Okay. All right, so the element has a half-life of 58 minutes. Do you guys know what half-life means?
No.
Okay, write an exponential equation to find the portion of mass of nobelium, I guess is the name of the element.
Nobelium?
Nobelium, yeah. That is left after X minutes, and find what percentage of an amount of nobelium, what is it? Nobelium? They should put an accent over that second symbol. Is left after 15 minutes. Okay, so half-life of 58 minutes. What's left after 15 minutes? So the equation will be in this form. Y equals AB to the X. Since the question is asking for a percentage, A, which is the starting amount of material, is simply 1. Okay, so when you start, your percentage that you start with is 100%. So you have 100% of your whatever it is. Okay, we know that half of the mass decays in 58 minutes. So that's what half-life means. Okay, so in 58 minutes, half of the stuff decays. All right, so use the data point to find the equation. So let's start with this. Y equals B to the X, because this is the original amount, right? So the percentage is just 1. So 1B to the X, or just Y equals B to the X. So we want to know so half of it, 0.5, equals B to the 58. Oh, sorry. That's bad. Yeah, so in 58 minutes, you're going to have half. So here's some information. Here's a data point. 0.5 is B to the 58. Okay? So basically, if I solve for B, how do you solve for B? Not divide it. What's the opposite of exponent? Not square root it, but 58th root it. So basically, the 58th root of 0.5 equals B. Okay? All right, now we're going to substitute 15 for X, because that's how many minutes we want, right? So we want, so this guy we're going to plug into our formula. So Y equals our B, which is a 58th root of 0.5. And then our X is 15 minutes. So see, after 58 minutes, you're left with 0.5, right? So to solve for B, you get 58th root of 0.5. So now you know your B, so now you can plug in any amount of time for your X. So your X represents how many minutes, okay? So then when you do that math, you can do that on the calculator. You get approximately 0.84. So this is how much percent is left after 15 minutes. So remember, half, 50% is left after 58 minutes. So 15 minutes, which is like a fourth of that, is that much decay, which that math doesn't line up linearly, right? So that's why it's called exponential decay. Okay, one more. An experimenter measures the maximum distance a large pendulum travels from its resting point at each swing. Okay, so for example, you can imagine a pendulum. So this is example 4. Your swing, and then your distance. So this is like your XY chart. So 0 swings, the distance, hold on. Okay, so at 0, it's going to swing 2.17 meters. Okay. So a large pendulum travels from its resting point at each swing. So the first, basically at 0, it goes 2.17. The measurements are recorded in this table. So 3 is 1.5. That's how far it goes after 3 swings. After 6 swings, it travels 1.04. 9 swings, 0.72. 12 is 0.5. And then 15 is 0.34. So do you understand the problem? So you know how a pendulum will slow down after a while and it travels less distance. Okay, so use the table of values and graph. So if I graph this, it would look like this. So we've got a y-intercept, right? This is our swing. Our y-intercept is right here at 2.17, which is about right there. Is that, you guys feel okay about that? 2.17. So at 3 swings, I made this too big, but at 3 swings, it's going to be 1.5. So at 6 swings, I'm going to redo it. I'm sorry. We just saw the Parks and Rec episode with the 10,000 candles and the 5,000 candles in the wind.
Oh, yeah.
Remember? Bye bye, little Sebastian. Awesome. 2.17 at 3 swings, it's 1.5. 6 swings, 1.04. 9 swings, it's 0.72. 12 swings, it's 0.5. So it looks like this. Do you see the decay here? It kind of levels out a little bit. There it curves. It looks like it's linear, but it's just because the graph isn't awesome. Okay. So use the table. Okay, we did that. The graph shows that this problem is a case of exponential decay. So the equation will be in the form y equals ab to the x. Okay. So here's our data point. We know that at 0 swings, it's going to be 2.17. So 2.17 is at AB to the 0. So remember, this represents your x value. Okay, so at 0, it's 2.17. Well, what's B to the 0? 1, right? So guess what A is? 2.17. So now you have so A is basically kind of like your starting amount, your principal, right? So y equals 2.17 times b to the x. So here's your equation. Well, let's just plug in another value to figure out what our b is. So at x equals 1, at x equals 1, which will get basically put b, give me b. Well, we don't know what x equals 1 is. We do know what x equals 3 is 1.5. No. What'd you do there? Okay. Oh, yeah, 3 is 1.5. So 1.5 equals 2.17 times b to the third. So how do you solve for b? Divide by 2.17 and then find the cubed root of that. So divide by 2.17, then find the cubed root of it, and you're going to get b is approximately 0.88. Okay, and then you have your equation. So this is, if you ever wanted to calculate that in a pendulum swing, you got it. All right, so this is exponential growth. Most of the time, this is just plug and chug, okay? But there is a time where you have to calculate your data points. So your principal amount, and then you can use any of these all this data to help you basically write an equation for this exponential growth or decay, okay? Don't stress too much about this. When we take our next test, it'll be easy. We'll go over it and make sure you got it. And I think the next test is going to be just a plug and chug, okay? So have your calculators handy and you'll be fine. All right, let's move on to 58. Oh, yes. Back to some good old algebra. We're going to solve quadratics by completing the square. So Elena is taking college algebra at Red Rocks for another math credit or whatever. But, oh my gosh. This is not going to be public, but the teacher, like she Zooms with her and it's just her writing down, and she talks like this, and she talks like this. I'm like, come on. The stereotype for math teachers is already bad enough, but this, it's terrible. I'm sorry. If you're watching this, I'm sorry. Maybe consider another career, like a librarian or something. Okay, but the other thing that is really bad is that her microphone feedbacks every time she talks. So it's like, it's terrible. Sorry, just a little vented. But they did completing the square yesterday, and Elena was like, she does it way different than you. And I'm like, most people do things way different than me. So they don't talk about butt cheeks and tats. Sorry. I can't imagine this person even thinking about that. Okay, so we're going to complete the square. Okay, so we're going to start, and the way, and this is the other thing, this is why we brought this up, is because all math curriculums teach it the same way and I teach it different, okay? It's just a little different, but I think my way is easier. And I'm standing on that. But if you know it a different way, you're welcome to do that, okay? So the first thing they talk about is the square root property, where if x squared equals a, then what does x equal?
Square root of a.
Okay, that's half right. Don't forget the negative counterpart, okay? So there's always two roots. That's the deal. If x squared equals a, and you can also write this, x equals positive or negative square root of a. Okay? All right, now, and that has to be for any a greater than 0, because you can't take the square root of a negative number. Are you going to sit like that the whole class period? Because It is comfortable, too comfortable, because if I was sitting like that in a math class, I'd probably fall asleep.
I would never do that.
I think you have.
This is too engaging.
This is a good lesson. All right. Talking about finances is not very exciting, but you'll like this. Okay. And I like it when you engage because you're smart and it's fun.
You call them smart, that's funny.
You are. The only thing you're dumb about is thinking that you're not smart.
Ooh.
Okay, here's example 1. A. So that means there's a B.
Yay.
Okay. Yay. So we're going to solve by completing the square. Now, usually in the past, what we've done is, okay, well, let's try to solve by factoring. How do you solve by factoring? Oh, look.
It's common facts.
You factor first. That's the first step. You're looking for that. But if you're solving by factoring, you get everything on one side. So if you bring this 9 over here, this would make this a 16, right? And then you ask yourself, okay, what factors of 16 will add to negative 10? 2 and 8. Oh, that actually does. That's so disappointing. But we'll start with this one because it's easy. So you can solve by factoring, and then it would just be x minus 8, x minus 2. And so x would be 8 or 2. Remember doing that? Now this is a different way. This is the way I want to do it. I want to solve by completing the square. So when we talk about square trinomials, these are square trinomials. What does it mean to be a square trinomial? Do you guys remember talking about this?
Aren't all trinomials square?
They're quadratic, but they're not square. Square means you can take the square root of it. If something times itself.
Right.
So what makes these? So because this is, if I did this, this is just x plus 1 squared. This is x plus 2 squared. This is x plus 3 squared. X plus 4 squared, x plus 5 squared. Okay, so these are square trinomials. There's also a very recognizable fact when you're dealing with a square trinomial. Do you remember how to figure out this number if you're given this number? Do you remember that? So this number is 10 divided by 2 squared. So you cut that middle term in half and you square it, and that'll give you your constant. Look, 6 divided by 2 is 3. 3 squared is 9. 8 divided by 2 is 4. 4 squared is 16. So basically, we want to create a square trinomial. So let's see here. We have to figure out what to add to this to make it a square trinomial. I'm going to go. So the first step in my method is to put your variables on one side and your constants on the other. Okay, so then you're left with a negative 16 over here. So you want to figure out what you're going to add to both sides. So how do you figure that out? You complete the square. Divide that by 2 and square it. What do you get? 25. So that's what you're adding to both sides. So then now you can factor this. Look at this. This factor is x minus 5 parentheses squared. And then this is just 9.
Where'd you get the negative 16?
I brought the 25 over here. So what Saxon does is they leave it there, and then you have to figure out what will turn that into a 25. But even though that it already is 25 right now, they're kind of doing something different. So like if this was 23, you'd say, okay, I have to add 2 to both sides. I think it's just easier to get everything on one side, clean your desk off, and then figure out what you need to add to both sides. This is how I do it different. Okay, so after you factor it, you get this. Now, how do you get rid of that square? Square root it, right? So then you get x minus 5 equals positive or negative 3. Are you done? No. What do you have to do to get x by itself? You have to bring this guy over here. So x equals positive 5 over here plus or minus 3. It equals 8 or 2. Okay. Let's do another example because this one was pretty much done for you. Let's do 2b. So how do you find the missing number in a square trinomial? What do? How do you find the constant in a square trinomial? What do?
You, I mean, it depends. Oh, the constant, right? So you take the second x.
Yep, the x term's coefficient.
The coefficient of the second, yeah. You divide it by 2 and then you square it.
Good. Okay, so this is already done for you, right? Because look at this. What's half of 24? 12. So, and 12 squared is 144. So this is already done. So all you have to do is factor this. How does this factor?
X plus 12.
Yeah, x plus 12, or x plus 12 parentheses squared. Now what?
Now square root it.
Screwed it. So you get x plus 12 equals positive or negative square root of 5.
12.
Oops. Okay, now what?
No, minus 12.
So subtract 12. Minus isn't a verb.
Subtract 12.
Or just put it over there. Same thing. Negative 12 plus or minus the square root of 5. So if you leave it in this form, then you can just do that. Instead of saying positive or negative square root of 5 minus 12, it's easier just to do it like that because this symbol makes more sense that way. All right? So that's when it's already in a square trinomial. So let's do an example where it's not. So here's example 2. X squared plus 18, no, it's not there. I'm just skipping to example 3 because example 2 just has you find that third one. Okay, here's example 3. X squared minus 14x minus 8 equals 0. What's the first step? What's the first step? I already wrote it. What's the first step?
Variables on one side equals constant on the other.
Okay, so we're going to just leave a blank here because we know we're going to add something to both sides. Okay, so we're going to have like an x squared minus 14x. We'll just use this example. Okay, so what's the next step? How do we figure out what will make this a square trinomial? Because right now this isn't a square trinomial. Okay, divide the 14 by 2 and then what? Square it. So what do you get? $49. Good. All right. And once you do that, step 2 is complete the square. This is the completing square step. So complete the square. means divide x term coefficient by 2 and square it. And then what you're going to do is add to both sides. Because you can do whatever you want. You can make a square trinomial on the left side, but you have to pay the price. You can put whatever number you want over here as long as you put it over here. So now this is a square trinomial. What do you do next?
Factor it.
You factor it.
7.
So how does this factor? Yeah, x minus 7, or x minus 7 squared equals, let's do that math, 57. And then you screw it both sides, right? You square root both sides, and then you solve for x. You square root both sides, what are you left with on the left?
X minus 7.
Yeah, you're just canceling that. That was the whole point. And then this is positive or negative square root of 57. Okay?
X equals negative plus or minus square root of 57.
So x equals 7, positive 7, because a negative 7 over there becomes a positive 7 over here, plus or minus the square root of 57. Okay, this happens a lot in real life quadratic equations, that you have an irrational answer. You have two irrational roots. 7 plus that messiness and 7 minus that messiness. But yeah, so I'm going to do one more example and make sure you guys get this. This is lesson 58. Let's do one of the questions here in your problem set. So you definitely want to write this down because this is part of your homework. Oh, those are too easy. Guess we'll do it. So we can do 8 and 9. So here's what 8 says. X squared minus 8x plus 16 equals 3. Okay. What was that first step? Well, you don't want to do the first step, because here's what happens is now you're at step 3, because you've already completed the square, because on the left side is a square trinomial. Raise your hand if you recognize that it's a square trinomial. How do you know if it's a square trinomial?
Since it was divided by 2 or
Yes.
square it, then it equals 6.
Yeah, if you divide 8 by 2, and really it doesn't matter if it's positive or negative at this point, because you're dividing it by 2 and then squaring it. So squaring a negative and squaring a positive, you're going to get the same answer. So 4 squared is 16. Okay? So then we skip to step 3, which is?
Where are you pointing?
Oh.
Oh, factor both
it, so it's,
sides.
negative 4 x.
So how does this factor? Somebody besides Drew?
X, is it minus or plus 4?
It's
Yeah.
Minus 4
Nice.
equals
Squared.
squared.
Equals plus or minus.
Yeah, equals plus or minus.
Well, not plus or minus yet, because we haven't taken the square root of it.
Minus 16.
No,
No.
we already did that.
Well, this whole thing equals that.
Oh, just 3.
That was the whole point is, oh, this is a square trinomial. So write it as a square trinomial. Now we can
It's just 3, so then you square root it.
square root both sides.
So it's just x minus 4 plus or minus 3.
Not plus or minus 3.
Not yet. Square root of 3.
Square root of 3.
Plus or minus square root of 3.
Okay.
And then add 4.
Add 4.
So x equals 4 plus or minus
Perfect.
square root of 3.
Good job. So that's number 8. That's one of your homework problems. Number 9 is already written as a perfect square, so all you have to do is factor and solve it. There's not any ones like this on your homework, which is disappointing.
Shame.
Well, I would want you to
Yeah.
practice that before test, but
Oh, is it on the test?
it might be, probably will be, because our next test will be after lesson, after lesson 60, so it won't be on the next test. Okay, you guys good?
Yeah.
All right.
Black math. Give me some math and I'll give you some flack. Black